All right, hello. So we've got a problem here looking at a siren. If there is a shark that is spotted, and we are given a little bit of information about the intensity of the sound and how it varies inversely with the square of the distance. So whenever I read the words varies inversely, that means I know one thing equals a constant divided by another thing. And so I just have to read it in order. I varies inversely with the square of the distance d. So I know just from that sentence right there that the letter I is equal to some number that I don't know divided by the square of the distance, so d squared. Now we're given a second clue. When the distance is 1.5, the sound intensity is 4. So when the distance is 1.5, the sound intensity is 4. So I can drop that information into my equation that I set up from before, and then I just need to solve for k. And the way you solve for k is you undo division. So the opposite of division is multiplication. So I'm multiplying by 1.5 squared. 1.5 squared is 2 and a quarter. 2 and a quarter times 4 is 9. So 9 is my k value. So then it says show that I equals 9 over d squared. Well, I just did. 9 is the k value. 9 is over d squared. So we have our equation I equals 9 over d squared. As we scroll down a little bit, now we're going to sketch the graph of it. What I know is that, for example, if d is equal to 1, then I is going to equal 9. How do I know that? Because I is equal to 9 over d squared. So if d is equal to 1, 1 squared is 1, 9 divided by 1 is 9. We already knew that 1.5 comma 4 was on the graph. So here's 1.5 and 4. We can label that point 1.5 comma 4. What I want you to notice is that as I divide by bigger numbers, I get smaller intensities. So if d equals 3, 3 squared is 9, and 9 divided by 9 is going to be an intensity of 1. As we keep dividing by bigger and bigger numbers, our curve is going to decrease like this. It's not exponential decrease, it's a inverse variation decrease. The difference is that as you divide by small numbers, you get bigger and bigger intensities. And the reason that makes sense is dividing by a small number gives you a big answer because it takes a lot of the small number to fill up the big number. In other words, if I divide by zero point 0.1, it's going to take a lot of those to fill up 9. Zero point 0.1 goes into 9 90 times. Zero point 0.1 squared goes into 9, I think 9,000 times. 900 times, excuse me, 900 times. So it goes up there quite a bit. Anyway, that's enough talking. That's the curve. Last part. While swimming, Scarlett can only hear the sound if the intensity is greater than 1.5 times 10 to the negative 6. So that's my intensity. Okay. So I want the sound intensity to equal 1.5 times 10 to the negative 6. But I also know that the sound intensity is equal to 9 divided by d squared. So I'm going to multiply both sides by d squared. So I have d squared times 1.5 times 10 to the negative 6 is equal to 9. And then I divide by 1.5 times 10 to the negative 6 to get d squared by itself. Okay. 9 divided by 1.5, 1.5 goes in there 6 times. And dividing by 10 to the negative 6 is the same as multiplying by 10 to the regular 6. So I know that d squared is equal to 6 times 10 to the regular 6 because I divided by a negative exponent. 6 times 10 to the 6 means you're moving the decimal 6 times. So we have the number 6 million. And then we take the square root of 6 million. Square root of 6 million. And that's not something I know off the top of my head. That would be very weird if I did. Square root of 6 million is 2449.49. And that does not quite answer the question. Let's be really careful. The question says find the values of D where Scarlet cannot hear the siren. That D value that I wrote down there is when the intensity is exactly 1.5. If we go past that D value, then the intensity will be less than that. So I'm just going to change this to D is greater than, and those are the distances where Scarlet would not hear the siren warning her about the shark. All right, there you go. Ask questions. Let me know if there's anything that was confusing.